Hello, everybody, and welcome, as Kanika said, to GTC, the second day of GTC. We're going to be kicking off an amazing schedule of telecom announcements. And what I thought I would do today is take a moment to really look at, in context, some of the very exciting areas of infrastructure build-outs. Yesterday, we saw perhaps the most exciting but also technologically advanced infrastructure that's leading the industry. The telecom industry cannot get left behind this. We are, 3 years into the AI revolution? And 3 years into this AI revolution, we are now seeing some of the biggest build-outs of infrastructure, IT infrastructure. But I'm here to tell you that there is now another additional infrastructure build-out that needs to happen. The infrastructure that connects the real physical world and deploys AI infrastructure into the hands, in a large scale, into the hands of everyone. That infrastructure is the responsibility of the telecoms, the cable MSOs, and the CDN providers to put that infrastructure in place to take this to the next level. And we call this infrastructure the AI grid. So it does seem, I must admit, AI is everything, everywhere, all at once. And I think we would be honest if we said some of it is a little bit overwhelming. But also, we know there's tremendous opportunity. How can an industry that's traditionally, I would say, hasn't been known for moving fast, there's murmurings, maybe some of you agree, hasn't been known for moving fast, not get overwhelmed by this rapid pace of innovation and opportunity. In a highly regulated industry, we're seeing, though, new companies being built overnight, multi-billion-dollar valuations. We're seeing older companies that have existed for a long time, experiencing never-seen-before growth. The telecom industry cannot let this opportunity pass. This represents the greatest generational opportunity for telecoms, and we cannot let this moment pass. So think about this in context. There are 3 tectonic forces at play. We've heard a lot already about the transition from general-purpose compute to accelerated compute. This compute architecture that existed for 60 years is rapidly being transformed, and a 1,000,000x performance increase over the last 10 years. We've also now witnessed the rapid pace of AI moving through perception AI, generative AI, physical AI, and now into the region of the next phase of physical AI, which is taking physical AI out to the real world. What we haven't perhaps been so obvious, or what hasn't been so obvious, is the third tectonic force that's happening. And why isn't it obvious? Because it doesn't really seem like a tectonic change that's happening. We're moving from 5G to 6G. Does that really seem like a massive change? If your answer is no, you haven't been listening and aware of what's going on. 6G is being born in the era of AI. This is the first time we are able to build an AI-native 6G and deploy 6G to be the fabric of AI. Now you understand why these three forces create a new trajectory for telecommunications, an unprecedented trajectory, and as I said, a generational opportunity. Jensen recognized this a while ago when he said, AI is redefining computing and driving the largest infrastructure build-out in human history, and added, and telecommunications is next. That was very, very perceptive about how these three forces are coming together. But let's take a step back. Traditionally, over the last few decades, the compute stack for telecommunications has essentially remained the same. Purpose-built on custom silicon with custom software. The alternative compute stack that's formed the basis of the cloud industry, which is the general purpose compute stack, hasn't really had the capability to support the telecommunications compute stack. There have been attempts, of course. We know there have been many attempts to virtualize that telecommunications stack. But now, with accelerated compute and the benefits of accelerated compute, we are able to, for the first time, merge the telecommunications stack into the AI stack. This is now creating not just opportunities, but also completely new KPIs for the industry. We are now talking about, in the concept of AI RAN, running RAN and AI on the same infrastructure, having the ability to have agentic flows within the AI operations, because now the RAN is all software defined. And you're able to operate in a deterministic way, real-time, at-scale application deployment. This convergence of the compute stack has never happened before, and there will be unicorns built overnight because of this capability. Should I say that again for the telecommunications people in the audience? It's really important to understand how important this change and how to take advantage of this change. Let me take a moment to just look at this bottom layer of the telecommunications stack, the land, power, shell infrastructure layer, and as it moves into the AI stack. Telcos, MSOs, CDNs have a unique advantage on that bottom layer. That bottom layer already, in many cases, exists. Land, power, shell is something that this industry has a tremendous capability and know-how on how to build and add connectivity to land, power, shell. That's the basis of the deployment of communications. This footprint spans MSOs, central offices, point of presence, and even out to the radio base stations. Built in reliably today, predominantly for voice, video, and data. This infrastructure, this base layer infrastructure, is what evolves into the foundational layer of the AI grid. And some telcos around the world are already starting to deploy this AI grid. As we're going through this learning, we're learning a lot about how that application layer needs to connect to the rest of the stack. But we're also learning about the importance of orchestration. One of those layers, remember, is the infrastructure layer. When you have a distributed infrastructure, the orchestration of that infrastructure is essential. And again, new opportunities are being created by companies that are able to now look at SLA-aware orchestration. Let's take a look. Don't believe me. Let's look at, firstly, 24 telcos around the world are already building AI factories. Telcos have a very important role because they're trusted in their regions. They also have connectivity to the population. They also have connectivity to the enterprises. And what we are now starting to see, all of those value propositions play an important role on the telco, as we call telco NCP, the Telco NVIDIA Cloud Partners. As I said, 24 telcos around the world are doing this, and many of them are moving into the next phases of deployment, having already built a successful business line on their first phases. These platforms are supporting local languages, local cultures, higher education research, government services, many of those applications that are trusted on the infrastructure. Now, as I said earlier, what's also very clear is that there is a large distributed infrastructure that exists today. What many of you may know also is much of that infrastructure is over-provisioned for voice, video, and data, meaning it has excess power. But just the power that goes out to those locations. If you think about the need for power to drive the AI infrastructure deployment, what a golden opportunity this is for the providers of this infrastructure. So again, a large, massive, untapped AI opportunity that hasn't existed before. Now this is the money slide. Literally, the money slide. We get asked all the time, wow, what's the killer app? Have you heard that question? Have you asked that question? The ability to provide tokenomics, tokenization in that distributed network of value is very, very unique to this infrastructure. Why? Because the value is created by the ability to provide the applications that are token dependent. Time to first token, uplink tokens, tokens per second. All of these have different value, and I will show you some examples of why that value creation is so dependent upon the network and the ability to not just provide the application, but provide the application with the quality of experience and the monetization opportunity that's important. Yes, over-the-air network slicing has a role to play, but tokenomics, the basis of this new economy that we're living in today, that's driving the infrastructure decisions, is really what you should focus on. Bits over the air convert to tokens over the air. Bits through the infrastructure, through the switches, through the routers, through the overall infrastructure, convert to tokens. Token-aware routing, for instance. But these applications, deterministic latency, when you need to understand what the latency is of the application, it's not just the network that plays a role, it's the compute as well. The compute infrastructure. Imagine being able to load up an environment into KV cache so that that environment, any anomaly that happens instantly can be detected. That's a compute infrastructure implementation of network latency. These applications, concurrency, servicing a population, hundreds of thousands, millions, with an application so the quality of experience is correct so you can charge the monetization of that application. Vision AI, I'm going to show you a little bit of some of these examples, but Vision AI is one of the fastest growing applications. The ability to have concurrency, but also have vision language models deployed in the network so that real-time actions can be taken based upon what the camera feeds are showing. Again, nobody needs to watch these applications. The vision language models take care of that. And we'll see some examples of hyper-personalization and, of course, tapping into the ad revenue opportunities that means. So let me give you an example first. What you're going to see here is a partner that we work with, Personal AI, has developed an application for small, medium businesses. This application you'll see first running on an LLM in the cloud. And then you will see the same application that's been optimized for an SLM that's running on the grid. Listen to the difference in the latency of this application. Okay.
Hello, welcome back to Speedy Auto Repair. How can I assist you today?
Do you service vintage cars?
We service most domestic and import vehicles.
Okay,
For
thank
vintage
you.
Cars.
Do you also offer brake services?
Yes, we have brake services. Hello, welcome back to Speedy Auto Repair. How can I assist you today?
Do you service vintage cars?
We service most domestic and import vehicles.
Okay,
For
thank
vintage
you.
Cars.
Do you also offer brake services?
Yes, we have brake services. Hello, welcome back to Speedy Auto Repair. How can I assist you today?
You could also see the cost of that application based in the cloud and based on the local infrastructure, on the grid. What you're going to see on the next video is a personalization video. The original video is below. The application is now personalizing, and you can imagine the revenue opportunity by personalization. It's personalizing the video. But what you can also see in this, as I play it, you'll see it's servicing a large number of concurrent users, and jitter in the cloud is being mitigated by software mitigation. There's a threshold at which that jitter, as shown by the variation in frames per second, there's a threshold at which the software can no longer deal with that mitigation. And so now you will see also, you will see that same personalization happening on the grid, and the proximity, just the proximity of this application to the end user, you'll see the difference. Okay, let's see how it plays. So you can see the frames per second. You can see the difference in jitter on that personalization app and on the insert of the product app as well, and insert the product into the app. Quite remarkable, just based on proximity. Okay, this isn't just yet experimentation. We have now large partners, large companies that have recognized this opportunity and are building this opportunity into their businesses. AT&T, one of the largest, already has a large connected IoT network with hundreds of millions of connections, including connected cars. Now AT&T, Cisco, and NVIDIA are teaming up to turn this IoT network into an IOIT network, an Internet of Intelligent Things. what Cisco and AT&T are able to do on the NVIDIA RTX 6000 server edition GPUs is able to demonstrate an end-to-end performance and security. And in fact, Cisco are announcing their Cisco AI Grid, which is a full stack solution that's zero trust, on demand, and adding those GPU RTX 6000 server class GPUs into their UCS servers. The first example and use case of this is in Dallas for public safety, and it shows how that edge AI action-oriented vision language models can really improve operational safety at scale. Thank you. Comcast perhaps has the largest edge compute network, reaching 65 million locations. Now Comcast, through their work also with personal AI and Descartes, have recognized how that proximity, just milliseconds from their end customers, is able to now bring in hyper-personalization ads into the stream out to their customers. The same time, SMBs, small, medium businesses, can take advantage of those personal AI assistants. A tremendous opportunity that Comcast is already starting to grasp. Thank you, Comcast. Spectrum. Spectrum is working with movie makers. Movie makers need low latency, collaboration, the ability to create and collaborate on 3D, very complex rendering. Spectrum is looking to transform thousands of its data centers and hubs, which are all within less than 10 milliseconds of those studios, and deliver a low latency GPU-based network. Again, working with NVIDIA RTX 6000 Pro server edition GPUs. This is a more economical way for many studios to have access to low latency capability for rendering. Thank you, Spectrum. Akamai has already announced how they have 4,400 locations around the world on their distributed AI inference at the edge. And many of those locations now, they are bringing into their global AI orchestration capability. Global AI orchestration is required to enable SLA-aware distribution of content and SLA-aware application distribution. This is a blueprint that Akamai want to deploy around the world. Thank you, Akamai. And now, let's turn our attention a little bit to something I said earlier, the radio access network. Many telecom operators around the world have recognized the changes that are happening in this infrastructure. As I said before, general purpose compute wasn't really capable of virtualization. With accelerated compute, AI RAN was born. AI RAN, about 150 companies around the world, as part of the AI RAN Alliance, I encourage you to go see the booth of AI RAN Alliance on the expo floor, have already started to demonstrate significant advantages and benefits that they're seeing in AI for RAN, AI and RAN, and AI on RAN. Of course, as you saw earlier, not all the distributed sites will be RAN capable, but many, and an increasingly number more are as operators move to an AI RAN infrastructure. AI RAN, of course, enables RAN to run alongside the AI application, and there are tremendous benefits to enable them to do that. Here, what you're seeing is actually a grid of distributed sites that can be orchestrated, and one of the workloads, just one of the workloads, is a RAN workload. So now when you bring service level agreement and KPI-aware orchestration into a single pane of glass, and you add radio access network on top of that, you get a very highly utilized network that can deliver quality of experience and quality of service on demand. We are very pleased to announce that T-Mobile is integrating physical AI apps onto the AI RAN-ready infrastructure. Up until now, thank you. We have been working with T-Mobile and Nokia in the AI RAN Innovation Center together with Ericsson, who port their software onto the RAN software onto the AI RAN infrastructure in the AI RAN Innovation Center in T-Mobile. Already in a very short space of time, T-Mobile's now working with a very large ecosystem of application developers to also bring applications onto that very same infrastructure. And they have been already deploying this into the city of San Jose on vision analytics. What we are able to do at NVIDIA is bring this ecosystem of application developers into this same AI infrastructure with applications that are built on NVIDIA Metropolis, the most recent VSS, Video Search Summarization, version 3 blueprint, for instance, can bring agentic actions created by what those video language models are seeing real time. In the city of San Jose, it's being used to, over the T-Mobile network, to look at cameras or see cameras with a 5x improvement in performance of speed of performance of seeing actions at a traffic intersection. Just think what's happening there. Cameras seeing the traffic intersection, an anomaly happens, 5x they can act faster over the T-Mobile network on the AI RAN infrastructure. So new partners you're seeing, FogSphere, Levitas, LinkerVision, Vido, new applications in buildings to inspect and validate AI to telecommunications infrastructure, city intersections. The world is connecting now. Billions of the applications and things in the world are connecting now into the AI infrastructure over the radio access network. Thank you. And now let me take a slightly different view on AI RAN and the AI grid. In Indonesia, IOH, Indosat Ooredoo Hutchison, announced a while ago they're an NCP. They're building AI infrastructure. They're training in local languages, local dialects. They now want to deploy these AI applications to their population within Indonesia, spread over an archipelago, where ARPU is relatively low. This can help close the digital divide. They're bringing education, agricultural information to farmers, healthcare applications. They're building this within a center of excellence that we are working with them on in what we call NVIDIA AI technology centers to train the population on how to develop these applications. They're deploying it now on their Sahabat AI app to the population. This is being enabled by the real AI grid, the AI factory connected to distributed AI sites. so it can be delivered at the cost structure for the country and meaningfully for the country to close that digital divide. Thank you. So all of this that I talked about, I mentioned somewhere RTX Pro 6000 server edition GPUs. I mentioned somewhere an infrastructure of orchestration. I also mentioned applications. What I didn't mention was models. You heard yesterday, and you'll hear a lot more this over the course of this week, about the open source models that NVIDIA is bringing to enable this rapid development of applications and deployment of applications. This is our reference architecture to give those OEMs, to give the customers a rapid on-ramp into the deployment of the AI grid. This reference architecture has brought in a new ecosystem of partners. Some of these names you'll recognize, but there will be names that you don't. Each one of those partners has rapidly embraced this concept of AI grid, of opportunity for their business, and has created now an opportunity not just for themselves, but also for the partners they work with, as they integrate their full application or their orchestration layer through this reference architecture. So let's take a look at how this works.
AI is reshaping how we get answers, consume content, and run the systems we rely on. For AI to stay responsive and economical at scale, it has to move closer to where data is created and intelligence is used. That requires a new kind of infrastructure that weaves intelligence into the telecom networks that connect us all. This is the AI grid. Connected, distributed sites operating as a unified, orchestrated computing platform. As applications come in, the AI grid control plane evaluates workloads, intent, and resources, then deploys tasks where priorities like latency, cost, and availability are processed across nearby distributed sites, turning video into real-time insight for traffic, safety, and public spaces. For physical AI, robots need more compute than they can carry, so they offload heavy tasks like speech and planning to the AI grid, staying lighter, smarter, and ready to interact with the real world. As these workloads scale across the grid, utilization stays high and GPU capacity doesn't sit idle. Over time, the AI grid doesn't just run workloads, it learns from them, anticipating bottlenecks and recommending where to add or shift capacity. With NVIDIA platforms, the network becomes a living AI grid, putting telcos and distributed cloud providers at the heart of how AI is experienced everywhere.
Thank you. So, as I said earlier, 6G gives us the opportunity to really think differently about the world that we live in 2 to 3 years plus from now. There will be a connectivity fabric that's absolutely required to connect these hundreds of billions of things, to bring in these things into the network, to make the network aware of the requirements and the needs. That cannot happen on 5G and 5G Advanced. We can start that journey in 5G and 5G Advanced, but the new capabilities of 6G, creating the network as a sensor, improving the spectral efficiency, improving the performance KPIs, all of this is required. But we must also do this in a very, very principled way. As we bring in new endpoints into 6G, it's important that 6G is defined around key principles. Key principles being open, allow that innovation to succeed. Don't have the vertically integrated stacks that don't allow innovation to come in. it's really important to open up the stacks, make them software defined. Secure, of course, goes without saying. End-to-end security built into not just the hardware, but the software, and opening up for transparency and being trustworthy. That when you have that number of endpoints, when the network is, the endpoints are so reliant and the capabilities of the network are so reliant upon what the software, how do you ensure that it's built in a trustworthy manner? So what we did, together with a group of other very, very names that you will recognize, operators, as well as equipment providers, as well as some government entities, we decided that we needed to come together to create this commitment that 6G will be built open, secure, and trusted. So I'm very pleased that we announced this about a week ago at MWC, and we're already starting to capture the mind share of many, not just these. So don't just believe what I say. Look at this slide, and you will never have seen a slide before like this in decades. This is the NVIDIA AI RAN computers, all running, again, you saw yesterday, from small to large. The computers run all the same software, the models, the libraries, and look at the number of radio access network partners that are developing software on these computers. Never seen before. This is the way the world is going. This is accelerated compute and what the benefits of accelerated compute can bring. We work in a world that can be thought of as three computers. A world of developing, a world of training and simulating and deploying. 2 years ago, we set out with a vision to democratize wireless research. We knew that innovation in a software-defined platform had to come in. 2 years from today, from when we announced the 6G developer program, we are at over 7,000 members in the 6G developer program. At Mobile World Congress last year, over 50 demos were built on these platforms. We have 375,000 downloads of Shiona link-level simulator with ray tracing extensions. But let's take a look at this new world of democratization of 6G research.
The physical AI era is here, and 6G will scale it, connecting hundreds of billions of humans, machines, and AI agents. But scale alone is not enough. AI-native wireless systems cannot be built with traditional test methods. With an NVIDIA Aerial Omniverse digital twin, developers can train, simulate, and optimize wireless systems in physics-accurate environments before a single change touches the live network. Developers can begin with built-in models or integrate their own. The platform is modular, designed for an ecosystem, and is already delivering. High-fidelity RAN digital twins evaluate beam-forming strategies and site design early in development. Site-specific ray tracing channel simulation evaluates new waveforms and AI algorithms. Scenario generation and calibration use field data to raise fidelity in ray tracing simulations. Workflows connect antenna physics to full-scale electromagnetic simulation to validate AI RAN systems. AI agents resolve network issues in autonomous networks in real time, validated in digital twins. And in the cloud, simulations scale from a single base station to an entire city on demand, linking simulation with training and deployment for continuous iteration. This is how future networks are built. With NVIDIA Aerial Omniverse Digital Twin, developers design, validate, and iterate AI-native networks in simulation before they enter the real world.
So what you can see, of course, from that, in 2 short years, the amount of technology and platforms that we're bringing to this industry. Of course, you can run 5G advanced in these simulations as well, but 6G will be born in simulation. That's what we're seeing with this research that's happening now. So, the AI native telco journey is a journey. It may be overwhelming, but it's a generational opportunity. Do not let that opportunity pass. So wherever you start the journey, it doesn't matter. But just start the journey. There has never been a better time to be in telcos. Thank you.